In this episode, we are taking on something every new technician thinks should be easy until real support calls prove otherwise, and that is mobile connectivity. Phones, tablets, and other mobile devices are expected to move smoothly between cellular service, Wi-Fi, and Bluetooth without the user having to think much about what is happening underneath. When that smooth experience breaks, the complaint usually sounds simple because the user says the device will not connect, keeps dropping, or cannot find the accessory it worked with yesterday. The technician's job is harder because the real cause may be poor signal, a disabled radio, an incorrect setting, an old pairing record, a network problem, or a misunderstanding about how mobile devices decide which path to use for data. Once you learn to think clearly about those paths, mobile support becomes much less mysterious, and you stop treating every connection problem as if it were proof that the whole device is failing. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.News in the Bare Metal Study Guide series. Cellular connectivity is a good place to begin because many users assume their phone simply has service or does not, when the reality is more layered than that. A device using cellular service depends on the condition of its internal radio hardware, the presence of an active account, the identity information that ties the device to that service, the local signal environment, and the network capacity around it at that moment. That means a phone can have power, show bars, and still provide a poor experience if the tower is congested, the building is blocking the signal, or the device is struggling to maintain a stable link while moving between coverage areas. It also means a technician has to separate problems of registration, signal strength, and data performance, because a device that cannot place a call, a device that cannot use mobile data, and a device that connects but performs badly are not always suffering from the same underlying fault. Good support starts by understanding that cellular service is a relationship between the device and a larger provider network, not just a switch inside the phone. A technician should also understand the basic settings that shape how a mobile device behaves on a cellular network, because many support issues begin with a setting that changed and not with failed hardware. Devices can be configured to allow or restrict mobile data, use a preferred network type, permit data while roaming, and switch intelligently between available service conditions based on signal and network policies. If the user accidentally disables mobile data, the phone may still show service for calling and texting while apps stop working the way the user expects, which can feel confusing if the person assumes bars always mean full internet access. If the device is set in a way that favors a weaker connection method in a difficult location, performance can feel slow or unstable even though the phone is technically still connected. That is why support thinking should include not only whether the radio is active, but whether the settings match the user's situation, because the device may be behaving exactly as configured while still producing a poor real-world experience. Bad signal conditions create some of the most common mobile complaints, and they are easy to misunderstand because people experience them emotionally rather than technically. A user may insist the phone is defective because calls break up in a parking garage, the data connection becomes erratic in a crowded stadium, or a tablet works well by the window but poorly in the center of a large building. In many cases, those are normal outcomes of radio behavior because walls, metal structures, weather conditions, distance from the serving equipment, and heavy local demand all affect how cleanly the device can maintain a useful connection. The key lesson for a beginner is that poor signal does not always look like total failure, because sometimes the device still shows some service while struggling with speed, voice quality, or reliability. When technicians learn to ask where the problem happens, whether it happens to other devices nearby, and whether movement changes the behavior, they stop blaming the hardware first and start testing whether the environment itself is the real source of the complaint. Wi-Fi introduces a different kind of support logic because the device is no longer relying on a cellular provider network, but on a local wireless network that still has several layers of dependence underneath it. A mobile device must be able to detect the network, authenticate to it, stay associated with it, receive usable network information, and then reach the services the user actually wants. That means the device can connect to Wi-Fi, and still fail to reach the internet if the local network is having its own problems, which is one reason users often say Wi-Fi is connected but nothing works. It also means saved network information can matter, because a device may try to rejoin a familiar network automatically even when the settings for that network have changed or the local conditions are no longer good. A technician should always keep in mind that joining a Wi-Fi network and successfully using that network are related but separate events, and support gets much easier when you stop treating them as if they are the exact same thing. A lot of dropped Wi-Fi connections are best understood by looking at context rather than by rushing into hardware suspicion. If every device in the room is having trouble, that points much more strongly toward the network or environment than toward a defect inside one phone or tablet. If only one device keeps disconnecting while others stay stable, then the technician can start thinking more seriously about that device's saved settings, local software state, radio behavior, or physical condition. Distance matters, building layout matters, and the surrounding signal environment matters, because a user walking farther from the wireless source or moving into an area crowded with competing signals may experience slower performance or repeated drops without realizing anything has changed except location. The technician's advantage comes from translating the complaint into a pattern, because a device that never connects, a device that connects briefly and drops, and a device that stays connected but has poor speed are three very different stories that should not be treated as one generic Wi-Fi problem. Even when Wi-Fi is available, the experience the user gets depends heavily on how the device and the local network interact under real conditions. A stronger signal does not always mean better performance if that network is overloaded, badly managed, or suffering interference from other nearby equipment using the same airspace. Likewise, a weaker signal is not always catastrophic if the network is clean and the user's workload is light, which is why some people can still browse comfortably in places where another person trying to stream video becomes frustrated. Mobile devices also make decisions about when to stay on Wi-Fi and when to give up and shift towards cellular data, and those decisions are not always obvious to the user in the moment. That matters because users may blame the wrong connection type for a slowdown or a drop when the device was actually in the middle of changing from one network path to another. So a technician has to think about transition behavior and not just about the connection the user believes was active. Bluetooth is usually the most personal of the three major mobile connectivity methods because it is often used for headsets, speakers, watches, keyboards, cars, styluses, and other close-range accessories that users expect to feel immediate and effortless. Underneath that easy experience, though, Bluetooth relies on discovery, pairing, trust, stored relationship information, and support for the particular function the user wants to perform. A phone may see an accessory without being ready to use it correctly, and it may remember an accessory even after that remembered relationship has become stale or conflicting. This is why a device can sometimes show that it knows about a speaker, headset, or keyboard while still failing to connect in a usable way. A new technician should learn that Bluetooth problems are often about relationship management rather than about distance alone, because the device and accessory must not only find each other but agree on how they are supposed to work together. Pairing failures are common, and they become much easier to understand when you stop treating them like random behavior. A Bluetooth accessory may fail to pair because it is not in the right mode, because its battery is too weak to maintain stable communication, because it is already trying to reconnect to another device nearby, or because the phone is holding on to an old and now unhelpful pairing record. Users often describe this as the accessory not being seen, even when the device actually sees it briefly and then loses the attempt to complete the relationship. Range can matter, but so can clutter, because some environments are full of competing short-range signals that make discovery or stable operation less smooth than users expect. A technician who asks whether the accessory was recently used with another phone, whether the failure is consistent, and whether the accessory appears but will not finish connecting will often get to the truth much faster than someone who simply turns wireless on and off and hopes the issue disappears. Airplane mode deserves special attention because it creates confusion far out of proportion to how simple it looks on the screen. Many users think of airplane mode as a single all-or-nothing state where the device becomes disconnected from everything, but mobile devices often allow certain radios to be re-enabled individually after airplane mode has been turned on. That means a phone might be in airplane mode, yet still use Wi-Fi, or still be paired with a Bluetooth accessory, depending on how the settings were adjusted after the main mode was enabled. Support problems happen when the user forgets that sequence and later describes the device as behaving unpredictably, when in fact it is following exactly the combination of radio settings that were left active. A technician should think of airplane mode as a master state that changes radio behavior quickly, not as proof that all connectivity has been disabled forever. And that mindset helps explain many cases where users believe something is broken even though the device is simply obeying a setting they no longer remember changing. Data connectivity behavior is another area where technicians need a calm mental model because mobile devices constantly make decisions about which network path to trust and when to move between them. A phone that has both cellular service and Wi-Fi available may prefer Wi-Fi for one moment, then abandon it if the local network becomes weak or unusable, and the user may only notice that an app paused, a message took longer to send, or a video stalled at the exact time the handoff happened. Some users assume the active symbol at the top of the screen tells the full story, but the actual experience depends on whether the chosen connection has real working access to the needed service, not just whether the radio link exists at all. This is especially important when apps seem inconsistent, because one app may tolerate brief interruptions better than another, and background restrictions or service behavior can make a weak connection feel like selective failure. Technicians become much more effective when they stop asking only whether the device is connected and start asking whether the connection in use is truly healthy enough for the task the user is trying to perform. When mobile connectivity breaks, the best technicians think in layers rather than chasing the first visible symptom. The first layer is whether the radio path itself is active, which means the device must have the relevant feature turned on and capable of operating. The second layer is whether the device can see and join the network or accessory it needs, which includes signal conditions, pairing state, and basic compatibility. The third layer is whether the connection that has been established is actually usable for the intended purpose, because a joined Wi-Fi network without working internet or a paired headset without microphone function still leaves the user with a real problem. This layered way of thinking works well because it keeps the technician from skipping ahead to hardware replacement or blaming the provider, the network, or the accessory before asking the simpler questions about settings, relationship state, and signal environment that often explain the issue more honestly. Another useful skill is learning how users describe these problems in ordinary language, because their words often point to the wrong part of the system even while still containing the clue you need. When someone says Bluetooth is broken, they may really mean the car will not reconnect automatically, the headset connects but does not route calls properly, or the accessory only works after repeated attempts. When someone says Wi-Fi is bad, they may mean the device joins the network but has no internet access, or that performance collapses in one room but not another, or that the phone keeps jumping back to cellular data. When someone says the phone has no service, they may mean voice works but apps do not, or that the issue appears only indoors, or that a specific location creates the problem every afternoon when the area gets crowded. The more carefully a technician translates those broad complaints into specific behaviors, the more quickly the likely cause comes into view and the less likely the diagnosis is to drift into blind guessing. What matters most is not memorizing every possible setting screen or every brand-specific menu path, but learning to reason about why modern mobile devices behave the way they do when they use cellular service, Wi-Fi, and Bluetooth. These devices are constantly balancing signal conditions, remembered relationships, user preferences, and available network paths, which is why a connection problem can appear to move around when the real issue is still the same underneath. Once you understand how dropped connections, pairing failures, airplane mode behavior, and bad signal conditions fit into that larger picture, the complaints start to sound less chaotic and more like patterns you can interpret with confidence. That is the habit to carry forward from this lesson, because technicians who understand the logic behind mobile connectivity are far better at separating a true hardware fault from a settings problem, a local network issue, an environmental limitation, or a simple misunderstanding about what the device was trying to do in the first place.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.